Okay, so we're going to look at our first example, which is CH4 molecule. So sebelum apa-apa, we're going to first look at the Lewis structure and molecular shape. So draw your Lewis structure for CH4. We're going to draw the Lewis structure because we want to see whether your central atom has any bonds or lone pairs. Okay, so that's your CH4 Lewis structure. And then you're going to draw your molecular shape. So if you have 4 bonds, no lone pairs, you're going to have tetrahedral shape. Okay, tetrahedral shape with, what's the bond angle? 109.5 degrees, right? Okay, so now back to your Lewis structure. You're going to extract information from your Lewis structure. So you have all single bonds. So that means you have sigma, 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 sigma. That means you have 4 sigma bonds around your carbon. So write that down. So around carbon, you have 4 sigma bonds. And do you have any lone pairs? No. So you have 0 lone pairs. Okay. If you have 4 sigma bonds in your Lewis structure, that means you will need 4 unpaired electrons. Need 4 unpaired electrons around carbon, in carbon atom. Okay, so then you're going to look at your hydrogen pula. So hydrogen also will form 1 sigma bond with the carbon. So each of the hydrogen has 1 sigma. Okay, tu je kan? That means your hydrogen will need, each hydrogen will need 1 unpaired electron. Okay, alright. So now that we've looked at what we need, so 4 sigma bonds around carbon, that means your carbon will have to undergo hybridization. So what is the type of hybridization at your central atom? It will be, kalau 4 maksudnya it will be sp3 hybrid orbitals, because sp3 hybrid orbitals, it has when you hybridize, you will get 4 sp3 hybrid orbitals. Okay, so now we're going to look at our valence orbital diagram. We look at our valence orbital diagram to see what we have, okay, in carbon. So we will start with carbon ground state. So carbon at ground state meaning the carbon as an atom. So carbon is in group 14. So that means you have 2s2 and 2p2 valence electronic configuration. So you're just going to fill in your electrons. So carbon at ground state, you can see it has astaga, has 2 unpaired electrons only. So you can see that you have 2 unpaired electrons in the 2p orbital. But we need 4 unpaired electrons in your carbon atom because we want to make 4 sigma bonds. Alright? So that means what you need to do is you will promote one of the 2s electrons into the 2p orbital. So let's do that. That means you're going to have, so that electron, this electron will be promoted here. Okay. So now how many unpaired electrons do you have? You have 4 unpaired electrons. Okay, happy face. Okay. But look at your orbitals. Your unpaired electrons, they are in different orbitals. These orbitals are not of the same shape, nor do they have same energy. So that is not good because then your overlap will be inefficient later. So what we're going to do is, we're going to make hybrid orbitals. Okay. Tengok balik at your Lewis structure, your carbon will have sp3 hybridization. Therefore, we are going to mix our orbitals. So, carbon hybrid. Tekan kiri sikit. So how? Which orbitals are we going to mix to make sp3 hybrid orbitals? We're going to mix one s on s1 of the 2s orbital and p3, right? That means 3 of the 2p orbitals. So I'm going to mix that now. Mix these mix these 4 atomic orbitals, and you will get back 4 hybrid orbitals. Okay, so the name of your orbitals will be sp3. Okay, now we have orbital of the same shape and energy. Okay, so that will give you efficient orbital overlap later. Okay, so you're just going to fill in your unpaired electrons like so. So now we have 4 unpaired electrons in sp3 hybrid orbitals. Okay, so now you have your carbon that is hybridized already. So now we're going to look back at our hydrogen. So hydrogen, you need 1 unpaired electrons. Let's see how many unpaired electrons do we have in hydrogen. So hydrogen in ground state is you have 1 electron. So that means just 1 electron. Okay, so you have 1 unpaired electron. That's enough, right? Enough? Yes, so that's enough. So you don't need to excite or hybridize ke apa-apa, okay? Okay, now that we have that information from your valence orbital diagram. Oh mak kau. Okay, sorry. Stop printing. So now, we're going to draw our orbital overlap. Okay? So, from your valence orbital diagram, highlight carbon hybrid and hydrogen ground state. So you're going to basically translate this orbital diagram and this orbital diagram into orbital overlap. So you're just going to draw, okay? So let's start with sp3 orbital. So sp3 orbital with 4 unpaired electrons of carbon. So sp3, your shape will be tetrahedral. Remember tetrahedral? Okay. So that is tetrahedral shape. So label the name of your orbitals, sp3. And it will be carbon atom. And you have 1 unpaired electron in each of the sp3 orbitals. Alright? Okay. So now, look at your hydrogen ground state. You have 1s orbital of hydrogen with 1 unpaired electron. So 1s orbital, dia spherical shape je kan? So you're gonna draw that. So draw bulat, the orbital overlap. So you have hydrogen, 1s. And then you have 1 electron. So now it's paired up. So draw that for each of the sp3 orbitals. So hydrogen 1s, so pair up electrons. Hydrogen 1s, pair up. Hydrogen 1s, pair up. Okay. So now, are we done yet? Is the orbital overlap drawing complete? Not yet. You have to show you have to label your bonds. So you have 1, 2, 3, 4 sigma bonds, right? Because you already overlap your 1s orbital of hydrogen with the sp3 orbital of carbon. So each overlap results a sigma bond. So now you have 4 sigma bonds. Okay, so that's your drawing for orbital overlap. So that is how bonding occurs in CH4 molecule. Okay, so now you can see which electron in which orbital are interacting with each other. Okay, and if you compare with your molecular shape, to make sure you're right, compare with your molecular shape. So your molecular shape, CH4 just now, it has this tetrahedral shape, right? So your orbital overlap also has a tetrahedral shape. So it should be about the same. Alright? Okay, so that's the first example.